Alright, today we're going to take a look at absolute value equations. Now, the definition for absolute value is that absolute value is the distance from 0 on the number line. Let's take a look at our first example, absolute value of x equals 8. Now, there are two numbers that are 8 away from 0 on the number line. So if we think about it from a graphical perspective, here's 0. And then I can go 1, 2, 3, 4, 5, 6, 7, 8 to get to positive 8, or I could go negative 1, negative 2, negative 3, negative 4, 5, negative 6, negative 7, negative 8 in that direction. So I have two numbers that are 8 away from 0 on the number line. So x could have a value of positive 8, or x could have a value of negative 8. So these are my two answers for problem number 1. Now, for problem number 2, I'm going to take 2x plus 3 and set that equal to 7. When I solve it, using the subtraction property of equality, I'll subtract 3 from both sides, end up with 2x equals 4, and one value I get is x equals 2. I also set up 2x plus 3 equal to negative 7. So when you set up an absolute value equation, you're going to break it into two different equations and solve each of those equations. On my second equation, I'm going to again subtract 3 from both sides using the subtraction property of equality, and I'll get 2x equals negative 10. When I divide both sides by 2, I end up with x equals negative 5. So the two values that I could have for x are x equals 2, x equals negative 5. Now, if you think you have this down, go ahead and try example number 3. Pause the video, come back, and see if you got it correct. So one equation that I'll set up for number 3 is 13 minus 5x equals positive 2. The other equation that I would set up is going to be 13 minus 5x equals negative 2. Now I'll solve each one of these simultaneously, and then I'll end up with two different values for x. Now, on the equation on the left, the first thing I'll do is use my subtraction property of equality. Subtracting 13 from both sides yields negative 5x equals negative 11. Using the division property of equality, when you divide both sides by negative 5, your result is x equals 11 over 5. Now that can't be reduced, so you can leave your answer as x equals 11 over 5. Now let's take a look at our other equation. Again, we'll just go ahead and solve that like we normally would. We'll start by subtracting 13 on both sides. We end up with negative 5x equals negative 15. Dividing both sides by negative 5, we end up with a value of x equals 3. So the two values of x that I get for number 3 are x equals 11 over 5 and x equals 3. Now if you think you have this down, go ahead and pause the video, solve numbers 4, 5, 6, and 7, and then check your answers with the video and see if you got these correct. If you want to go ahead and write down together, let's move on. For problem number 4, the first thing that we're going to want to do is get the absolute value piece by itself on the left-hand side. We're going to do that by adding 10 to both sides. When we do that, we'll get the absolute value of x plus 1 equals 22. Now, just like before, we'll split that into two separate equations and solve each one. Two equations that we separate this into are x plus 1 equals 22 and x plus 1 equals negative 22. When we use the subtraction property of equality, we come up with our two values of x equals 21 and x equals negative 23. Now for example number 5, same thing, we want to isolate the absolute value piece first. To do that, we'll need to get rid of the negative 2 by dividing both sides by negative 2. When we do that, we'll have the following result. The absolute value of 3x minus 1 equals 4. Similar to all the previous problems, we'll break this into two equations and we'll solve each one simultaneously. By now, I think you've got these down, so you can probably finish this one on your own and do examples 6 and 7 by pausing the video and then re-watching it to see if you got them correct. So the two equations will be 3x minus 1 equals positive 4, and then 3x minus 1 equals negative 4. Using the addition property of equality and dividing both sides, we will end up with our two values, x equals 1/3 or x equals negative 1. Problem number 6, the first thing we're going to want to do as we start to isolate the absolute value is we're going to want to move the negative 5 over to the other side. So we'll use our addition property of equality to accomplish that. Next, what we'll do is we're going to divide both sides by 3 so that we can isolate the absolute value piece. Finally, we've got our absolute value of 5x plus 10 on the left, and then a positive number on the right hand side. To solve this, again, now we're going to break it into our 2 separate equations and solve each one. By now, you guys are rocking this out. I know you've got it. So carry on, check your answers at the end, and see if we agree. Now our final result, after we apply the subtraction property of equality to both sides and then divide each side by 5, on the left we'll get x equals negative 3/5, and on the right we'll get x equals negative 17 over 5. So our 2 answers for number 6 are x equals negative 3/5 or x equals negative 17 over 5. Now for problem number 7, there's a couple of things we want to take a look at. The first thing is the 1/2, and we're going to need to go ahead and get rid of the 1/2. So to do that, we're going to multiply both sides by the reciprocal of 1/2, which is 2 over 1 or just 2. After we do that, we'll end up with the absolute value of 5 minus 3x equals negative 4. But here we have an issue. Here's a common error. People will start to set this equal, and really you can't do that because the absolute value is the positive distance from 0 on the number line, and we have an answer. We've got our equation set equal to a negative number, in this case negative 4. So this particular problem, or any problem similar to it, is going to have an answer that is no solution, because you can't have the absolute value of stuff equal to something that is negative. Absolute value always has to be positive. So the correct answer for number 7 is no solution.